All right, we are just a minute or two before the last presentation, the keynote from Anaïs. Servus, Anaïs.
Hallo.
Du hast mir vorher gesagt, du sprichst Deutsch, aber du sprichst nicht gern Deutsch. Wieso?
Ich habe in den letzten 15 Jahren nicht täglich Deutsch geredet. Deswegen
Okay.
ist mein Deutsch so ein bisschen komisch.
Okay. But if anybody wants to then ask you later on about cloud native security and they may not be comfortable with English, German works as well.
German works as well. I just might reply in English.
Yeah, that's fine. As long as you can understand everything that they ask you, and also the special different dialects we have in Austria. So hopefully you will have fun tonight in the party when you hear the difference between east and west and north and south.
Yeah.
Some different nuances.
As long as I understand it roughly.
I think you'll do. All right, quick reminder, because after this session, we're not done yet. We have the evening event. So I know I've said this like 10,000 times today, but I see still people now using their phones to capture the QR code. Register for the event. There will be food, and there will also be drinks, and it would be a great way to then get together and mingle. But now, watching at my time, it's exactly 4:45. Anaïs, what you are, and because I looked at your bio, a couple of things that stood out for me. First of all, you were the CNCF Ambassador of the Year in 2021.
Yeah.
It's a cool round of applause.
Thank you.
That means you've done a really good job in representing the CNCF worldwide. You're doing a lot of public speaking. You also have a YouTube channel that is centered around cloud native. So in case folks you don't know Anaïs's content, check it out. Last thing before I leave the stage to you is, because I asked you, what is the one thing that people should take away or memorize from this session? And you said, and I just repeat what you told me. Sometimes something as simple as a double registered phone number can cost millions. And this is something we want to avoid. So something as simple as a double registered phone number can cost millions. So security is a big topic. Security breaches, a lot of things can go wrong. Without further ado, Anaïs, enlighten us about Back to the Future in the space of cloud native security.
Amazing. Thank you so much. It's great to be here, and I know. Well, you want to clap or not? Thank you. Awesome. Thanks. Yeah. So I'm going to share with you how something as simple as 2 phone numbers registered in your system could be an indicator of an intruder, and things you can do about it ultimately. So this talk is back to the future in the space of cloud native tech security. My name is Anaïs Urlichs. And I want to get started with this quote. Most of you have probably already heard about this quote. There's an old saying that those who cannot remember the past are being condemned to repeat it. Now, usually we use this quote in the context of history, that we don't want to repeat basically the mistakes that we have done in the past. We can also use it in a more positive way, as in that if we already have invented the wheel, we don't want to reinvent it. We don't want to start from scratch if somebody has already a way of doing things. Now, I want to share with you what happened in the past 5 years. What are some of the major security incidences related to the cloud native space that we've seen, and security incidents that we can learn from? Basically, if we would have the same knowledge that we have today, 5 years ago, would we have done anything different? And what can we do today to prevent similar incidents in the future? So jump with me into the DeLorean and let's travel back in time. This is me 5 years ago in my first developer advocacy role. So I was actually at the time working for a company called Near Protocol, not in the cloud native space, but in the Web3 cryptocurrency blockchain space, talking to people about the decentralized web and decentralized policies and things like that. Now, long story short, I stopped believing in the space and I changed to the cloud native space. All of the things, maybe all of the conceptions that you have of the Web3 space, they are more or less true. So that kind of drove me away from those open source projects. And that's why I'm standing here now, talking to you about cloud native open source security related projects. Also 5 years ago, some other events happened. We lost 2 amazing people, amazing in different ways. Stephen Hawking dies on the 14th of March, and Avicii dies on the 20th of April. To more happy news, if you're into the royal family. William and Kate have their 3rd child on the 23rd of April, and this was before all of the Meghan Markle and Prince Harry drama, when they just got married and a happy couple. But this is not why we are here, right? This is not what I want to talk to you about, and it's probably not what you're really interested in. So let's talk about the past 5 years in the DevSecOps space. So DevSecOps, if you haven't heard that acronym yet, it stands for Development, Security, and Operations, and it's basically the idea that as we talk about our DevOps lifecycle, as we talk about how we want to combine development and operations, we also want to think around how can we integrate security and develop a security-focused mindset along the way. So at each step, it's a methodology similar to how there's not a DevOps engineer, but DevOps is just a practice that we implement across our different teams, for example, across our development, our platform teams. So some of the things that we can all agree on when we talk about DevSecOps, some of the principles that can give our stack better security, set us up in a better way for success in security terms. These for components, and I bet there are lots more, these are just the ones that I picked, is basically if we implement it, then we're in a better position, and our tooling is in a better position, our team is in a better position to identify security issues. The first one is that if we identify bugs early and also proactively fix them, then our systems are more likely to be secure and resistant to any failure. Now, the next one is shared ownership. I went to the talk earlier by the people from Red Bull in the other room, and they were talking about shared ownership in terms of shifting left, and everybody kind of is responsible and nobody's really responsible. That's not kind of the ownership that I'm talking about. When I'm saying shared ownership, first of all, in the security terms, we want to make people responsible for specific components of the stack and the security of those components. So you want to assign ownership of specific resources to specific people to ensure that things are actually getting looked at. The other part of shared ownership is that we want to empower people, no matter how junior they are, to speak up if things look weird, if things are out of the norm, if things are unexpected. And also take responsibility to all of the resources that individuals are managing as part of the stack. Next thing is automation. I love to talk about observability or best practices. I have done lots of talks on how you can implement security tools into your SRE stack. Now, usually when we talk about automation, we talk automation as part of like our CI/CD pipeline, GitOps, best practices, those sort of things. We don't really talk about how we can also automate our security scanning, our security best practices. And especially when we have a separate security team that's responsible, for example, for security scanning, then this can really lead to decoupled processes where we have our automation pipelines, but then separately our security tooling implemented. The last thing is that we want to some extent, implement the latest tech, but usually what happens, especially in the cloud-native space, that our user experience, our user tooling moves at a much faster pace than actually our security tooling. Our security tooling best practices, recommendations are kind of trying to catch up with that. So we want to be aware that if we implement new tools, that we can stay still up to date with the security components of those. So where did things go wrong in the past 5 years, and where do they still go wrong? If we can all agree on best practices as an industry and we all implement them, then why do things still go wrong and differently to how we expect them to go? Usually in the InfoSec, in the security space, between security folks, engineers, maybe platform engineers, there's lots of finger pointing going on who's responsible for what, and that also happens a lot when we talk about shifting left, shared ownership models, where there's not clear pipelines, clear processes defined. Now, I'm not saying you should set up a process for everything that you do, because also if you have too many processes, specifically like engineers, they're gonna try to find ways to go around those processes to reduce the burden of them. So here are some questions that I have for you, just to think about. They are taken from the Red Hat 2023 security survey. They interviewed around 600 different people and about security. So here are some questions from that. Do you think your organization does enough related to cloud-native security? Hands up. Do you think your organization does enough, does everything they could do? No, there was like one hand. Last week, I gave a similar presentation at Swiss Cloud Native Day. About half of the hands went up. Funny. So actually, 38% of respondents from that survey believe that security investments in containerized operations is inaccurate at their company, which is, as part of the survey, a 7% increase from 2022. Now, I didn't really look in detail at the surveys. There might be like other reasons for why that number went up. But if they would have interviewed you, then probably the number would have been much higher. Now, second question, have you ever been prevented to advance a tool based on security concerns? So you basically wanted to implement a new cloud-native tool, and then your security team said, you can't do that today. Did that ever happen to you? Okay, there's one hand. Yeah, a few hands. Okay, good, yeah. A few hands dispersed throughout the room. So in that case, actually 67% of respondents have had to slow down cloud-native adoption due to security concerns. A lot of times when you go to cloud-native related conferences, you will hear about all these fancy new technologies that people implement. And I talked to some people today, and they shared some tools that I wasn't aware of exist even, or that people would want to implement with me. So a lot of times we hear about these new technologies. Companies, they create solutions for their specific problems, and then they donate those solutions to the CNCF, and then everybody thinks they have to adopt those tools as well. Now, a lot of times, even if they want to implement it, even if they have cost to implement it, they might not be able to do so because of security concerns. Now, I will share with you some case studies on attacks, on security attacks. Here's just an overview of the different types of attacks that you might run into. Now, this is taken from Acra security documentation. I'm going to focus on these different attacks, more or less, in the next slides. Now, I added supply chain attack, because the supply chain attack can be like a result of different attacks or a specific attack that we talk about as an industry. So, software supply chain attacks. Basically, what is your software supply chain? Everything that touches your build process, your development process, from you choosing your libraries, you having the first meetings, to agreeing on features, all the way to shipping your code to production. That's all part of the software supply chain. Also the culture of your team, the processes you implement, anything that's part of it is part of your software supply chain, no matter what tool you're using. Third question, last question to you. I think, who here has discovered a security issue in their software supply chain in the past 12 months? Hands up. Come on, don't be shy. Okay. So my theory is that everybody has issues in their software supply chain. If you didn't put your hand up, you just don't look close enough. So more than half of respondents to that survey have experienced a software supply chain issue related to cloud native and containerized development in the past 12 months. That could be anything from like a CVE, like in their dependencies, like we saw in the previous talk, or it could be misconfiguration in your Terraform. Anything is part of your software supply chain. Now, if you look for software supply chain attacks, you will find lots of different articles on different companies. Let's start with the first one. Who has heard of CodeCuff? Hands up. Okay. Who has heard of their issue, of their security issue that they had I think it was last year. Oh yeah, 2 years ago, 2021. Okay, so who is working at CodeCuff? Somebody working at CodeCuff? No, you're not filmed. So, fun fact, actually one of my first roles, nearly 3 years ago, more or less, in the cloud native space. I worked for a company called CodeFresh, and CodeFresh does CI/CD pipelines, and as part of my work, I gave a tutorial, I showed a tutorial on how to implement CodeCuff in your CI/CD pipeline, and the way that I was told by CodeCuff to implement their tool was actually part of the security issue. So at the time, I actually spoke with my manager about that specific security issue and how it could be exploited, and then about 1.5 months later, it actually got exploited. So what happened is that they installed containers in your CI pipeline as part of you calling a bash script remotely. And the attackers basically managed to modify this 500-line bash script and change just one line. And the line just said, please send all the environment variables from the CI pipeline to our remote server. And that's what happened, that you used CodeCuff, you installed it in your CI/CD pipeline, your CI pipeline, and then it would send them your environment variables. Now, those environment variables were mainly used to access organizations' private Git repositories. Now, CodeCuff was very quick to, once they identified the issue with the help of a customer to then actually respond to it, they rotated credentials, they pulled third-party cyber forensic firms in to conduct an audit, so they did it like afterwards, all the right steps. If you compare different types of attacks and how companies kind of responded to them, you will find a clear difference in like the companies that are trying to be as transparent as possible about what happened versus those that tried to cover up as much as possible. Now, CodeCurve was very transparent about it, even though it took them a few months to identify what happened. They then managed to resolve it. Now, why is it a software supply chain attack? Well, it's in people's supply chain, and basically the attackers managed to find a way on how to modify their installation script. Also, the way it was identified by the company, by like one of CodeCurve's customers, is basically when you build a container image, you can put a signature on it of like, you built that container image. You can say, this is your container image. Now that signature had changed, and one of their customers realized that it's not their usual signature, and then they reported to CodeCurve. Next company, who has heard of SolarWinds in 2020? Yeah, probably most have heard of it in one way or another. Now, I'm going to share some of the details because it's actually an interesting like timeline that we can learn from. So basically, SolarWinds is kind of like an observability delivery platform as far as I understand. I never used them in any way. Now, they have different software components. One of them is called Orion. And the hackers basically managed to access the build and delivery pipeline of the Orion software and use that for the basis of their attack. So first they just tried if they can, once they had access to the Orion delivery pipeline, they just tried to modify it and see if then that modification would actually be delivered as part of the next update. They managed to do that, and then like a few months later, that's when they then implemented the malicious attack. So there was that opportunity, like a short time window, where SolarWinds could have identified that their original delivery pipeline was already being accessed by an unauthorized entity. Now, the attackers then mimicked the Orion software communication protocol so they could hide in plain sight. They managed to basically get their malicious code right in at the end of the build pipeline, right before the code is converted from human-readable code to machine-readable code to executable code, and then it was delivered to the different Orion customers. Now, ultimately, 18,000 customers downloaded malicious code between March and June 2020. Now, that didn't mean that those customers were automatically affected. In software supply chain attacks, there are usually multiple conditions that have to be true for that company to gain access to, for example, or like the attackers to gain access to your data and so on. So first you had to download the new Orion update, like it was just a standard update like how you would make other updates on your machine or on your service. And then you would have to deploy it, and the second condition was that the servers couldn't be in an air-gapped environment, they had to be connected to the internet. Now generally software supply chain attacks are more sophisticated because the attackers will need to find a way to basically break that factory seal that says that this software was built and delivered, for example, by SolarWinds. Now, once the attack was already executed, there were several different signs. There were several different stages where they could have identified that something was going wrong. So, for example, Palo Alto Networks is a security company in the space that provides enterprise platform solutions for your software supply chain and other components, other artifacts that you deal with, similar to Aqua Security. They also have a research team that basically tries to find loopholes in people's container software stack and so on. I will go into more detail on different examples later, but basically Palo Alto Networks discovered that there was a backdoor in the Orion software and traced it back with SolarWinds, to the component, but they couldn't find what was the actual issue, and that was that. Ultimately, it needed FireEye, another company, another customer of SolarWinds who are using Orion, to find that there is an employee within their company that has actually 2 phone numbers registered. Once they traced those, whom these phone numbers belong to, they realized that that employee didn't register for 2 phone numbers, there was only supposed to be 1. Generally, you should deal with your phone number as if everybody has it, because of security issues like that, because people use their phone number for 2-factor authentication and similar. Now, what FireEye then discovered was that over the course of several weeks that there was an intruder in their network, and someone has actually stolen the arsenal of hacking tools from FireEye that's used to test security of their own client's network. So basically, once you have somebody's, like for example, FireEye's internal systems, and you know how they tackle or try to identify security issues, you can then try to try to find ways around the security of one of their customers, for example, one of their clients. Now, FireEye called the FBI, put together a detailed report, and once it had determined that the Orion software was the source of the problem, they called SolarWinds, and that's then how they kind of released a patch, discovered the issue and released a patch. Now, independent of that, there were actually different signs at different points in time related to SolarWinds where you already worry kind of about the way that the processes internally and the way that they might deal with security. So, for example, a security researcher in Bangalore identified that there was basically on a public messaging board, there was login details to one of SolarWinds servers. They reported the issue and they just got like an automatic reply. Now, if you report something as serious as a password that's actually working, you would hope for a bit more of a reply than just an automated message. The other thing is, the other issue of why SolarWinds was such a nice target for attackers is that their website was basically described as a shopping list. So they detailed who of their customers is using the Orion software, which made it an easier target. So yeah, and basically, once you know that a company is already having some security issues on other parts, you're more likely, or attackers then more likely to try to find other loopholes on those companies, because if one thing goes wrong, then probably several other things might go wrong as well. Now let's talk about account hijacking. It's basically when your accounts are taken over by a malicious entity. Who has heard of the MGM case? Okay, it was just in the news 2 weeks ago. It's very, very recent. So MGM is part of like this $14 billion gaming giant as part of MGM Resorts. They operate over 30 hotels and gaming venues. No, gaming venues as in like gambling in Las Vegas venues. So they have hotels in Las Vegas, similar to how you have like Caesar Palace and other venues there. Now, the attackers, what they did is they found an interesting employee on LinkedIn and then contacted the help desk of MGM and requested for their password, for the details of that employee, like they pretended to be that employee and requested the details to be reset. Now, you might think, oh, not everybody can just pretend to be somebody's employee. With AI and voice simulation, I could pretend to be a middle-aged man, and you wouldn't necessarily know who's calling. So they basically, through that, managed to get the account details reset, and it was just a 10-minute phone conversation. And that shows that you don't always need sophisticated attacks in other cases. Now, there is a specific hacker group mentioned, but actually I found it across different articles. There are multiple different hacker groups mentioned who could be the attack. And I'm going to move quickly because I have 5 minutes left. So it's unclear who's actually behind the breach, but basically MGM is just one example of like a large-scale company that has been under like a very basic, let's say, attack because they are such a large company, or like hotel chains are usually targeted because for them it's easier to pay the ransom than to wait out the attack, because it's just causing so much chaos across their chains that they just pay whatever the attackers are asking for. So this is part of our software supply chain, is like our software supply chain is just as strong as the weakest link, and the weakest link is usually also just the people whom we're working with and whom we're interacting with. Here, just 2 other examples. It's really easy to get verified on the VS Virtual Studio Code Marketplace. You just have to verify your domain, and you can get verified and get people to download your extensions. So be careful with that. Another thing that has been like in the news a lot is repo checking, where basically your organization moves to a new domain. There is a link forwarding to it, but for example, somebody else then, if you didn't register or keep the old repository name on GitHub, for example, somebody else can register it and then pretend to be your account, and people who don't know that it's not your account will use the attacker's repository because the forwarding link then breaks. Now, here's another example of a company that has been careless with their credentials. It just been in use as well. This discovered that Microsoft actually, discovered a leak in Microsoft, basically, and how the AI researchers were handling their data and were able to access it. Now, CVS and vulnerabilities are another huge security issue. What usually happens is that we want to ship code, and then we are presented with our long list of vulnerabilities, and we don't know what to do with them, so we might not look at them at all. Security misconfiguration. Sorry, I'm rushing through it because I have not much time left. Security issues is another thing. Now, here's a database that I've showed in multiple of my previous presentations before because I love it. It just shows so much potential for improvement for this entire space. There are lots of basically misconfiguration that caused huge data leaks across different services. And you have here lots of like also really basic security issues, misconfiguration that could have been easily prevented. Now, this is a public database on GitHub. You can check it out through the link here in the source afterwards. And there are like things like, no, that the database was publicly accessible, 5 billion records. Like that could have been prevented, right? So what are some common patterns between these attacks? Usually, you are the last to know about these attacks. What I mean by that is you using somebody's software, somebody's tooling. They have a security issue, you use it, you are ultimately exposed through them, and they might identify that there's a security issue. They might be informed by companies such as Aqua Security that there's a security issue that they have to take care of, and then once they have a patch available, they will release the details. That's usually the process, if it's not such a dramatic attack. So you are usually the last to know, and then, like we've seen in the previous talk, you want to be able, like in a position, your stack should be in a position that you can identify where, for example, which libraries are used in your stack so you can easily mitigate the issues and implement a patch. Then security measures usually fail that we have in place. So I'm not saying that none of us has any form of security measures, security scanning in place, but the thing is we usually test them as if we make the changes, not that changes are implemented maliciously in our code. And I spoke about that also earlier this year in the case of security chaos engineering, how we can proactively identify or like verify that our security tooling is working as expected. And security issues are persistent. We have to deal with them for years and continue to educate people about existing security issues and ways to mitigate them or ways to find ways we found around them. So some solutions of today that you can implement right now. First of all, there are lots of enterprise solutions out there. Aqua, Sneak, CrowdStrike, Sysdig, Palo Alto, Wiz. These are just like really focused on the cloud native space as well. And then we have lots of open source tools. We have, for example, Sigstore. Who has worked with Sigstore before or heard of Sigstore? It basically allows you to sign your artifacts that you distribute to users, to your open source users, to your clients, so they can verify that you are the one who built that container image, built those packages, not somebody else. Kyverno was mentioned before as well in other talks. It's basically implementing policies in your Kubernetes cluster to have additional alerting set up, for example, if those policies are circumvented. Then Tracy is an eBPF-based monitoring tool that allows you to monitor specific events that could indicate malicious activity within your environments. So to specifically secure your software supply chain, you can, for example, with Tracy, implement that in your GitHub Actions and verify that the artifacts you build are actually aligned with what you expect and like run as expected as they're supposed to run. Now, there's an entire talk by one of my coworkers on verifiable GitHub Actions with eBPF as part of the previous KubeCon. So check that out if you're interested in like verifying the code that you built at runtime. And then there are lots of different security scanners out there, so you can really pick the one that's best for you and your team. Now, the thing is with security scanners, it's worth mentioning, has been mentioned before, they all pull from similar databases of vulnerabilities. The two main ways that they differ is, first of all, how they deal with false positives and false negatives. So, for example, Trivy takes a really conservative approach that they report less on false positives than reporting less on false negatives. And also, the other way they differ is like how you can manage the security scan itself. So this is just a blog post that I found actually today that was posted on our Slack community where somebody shared how they manage vulnerabilities once they identify it with Trivy. So you want to find ways on then not just identify vulnerabilities, but how do you manage and deal with those vulnerabilities long term. Secret scanning is another thing, and how you can, if you use especially third-party resources, when you deploy your own code, to identify if there's anything wrong, anything you might want to change before you commit it. Last thing I want to mention is culture. Who has heard of this quote before? Culture eats strategy for breakfast. Yeah, you can do as much as you want if the culture is not going to work in your favor. It's not going to make much of a difference long term. So you also want to always think about how can you implement the strategies I mentioned earlier related to shared ownership models in your software supply chain. Now, this is my talk. Thank you so much for listening. I hope you have an amazing evening, man.
Thank you so much, Anaïs, and sorry that I pressured you even more, but I think you definitely win the prize for most words per minute in the presentation. Really, it's also great because you're really passionate about this topic, and there's a lot of stuff that is out there. Yeah.
I want to share as much as possible as I can within the time.
And will you be at the party later on to share even more?
Sadly not.
No. Okay, then hopefully you will be here for another 15, 20 minutes.
I will be here for a bit longer.
So we still want to...
And Twitter, and here's also the link to my website. I have a weekly DevOps newsletter where I share all of the different tools that I come across at conferences and other things.
Perfect. I want to just say, make sure that you follow up because there's a lot of stuff out there. Now, we want to take a couple more minutes for questions. And we have our mic runners. So, who wants to challenge Anaïs with a security-related question? Come on, you can do it.
It's the end of the day.
It's the end of the day. I know they're all waiting to get home finally. Any questions? Here we go. Robert.
Trivi.
Yeah.
Software supply chain. Throwing out buzzwords.
Well, it's actually about Tracy.
Tracy, yes.
Yeah, I wanted to get started with Tracy, and I installed the Helm chart.
Yeah.
And I found out that the Helm chart it creates a config map that has the policies for Tracy.
Yeah.
And I cannot change that config map via Helm. So if I edit the config map and then do a Helm upgrade, my changes get revoked.
That's a big issue. So just to provide more context to everybody here, Tracy started off as a tracing tool. Like you would actually trace events similar to like how you would trace other events. Like on the user level, you would trace events specifically on the node level. Now, the functionality that's described right now is the functionality we have since like 2 months, where you basically install Tracy ideally through the Helm chart, and then you modify the config map that basically defines which kind of events Tracy is supposed to track. For example, if specific containers are running in your cluster, that's what you define through the Tracy policies. Now, because we just made those changes like 2 months ago, I didn't know that if you then redeploy the Helm chart, your config map gets deleted, and that's definitely a bug that I'm going to report right after. But your config map should stay persistent across Tracy updates, right?
Okay, thank you.
Yeah, that is unexpected behavior.
Does he still need to open up an issue on Git, or will you take this from him?
Pardon?
Does Robert still have to put in that issue on Git? Or will
No, I'm going to do it, don't worry.
Perfect.
No, oh my God, it's my responsibility. I need a job, you know?
Well, what I thought was really cool with all these stories, because I've been talking a lot over the last years about kind of the performance horror stories. Scalability horror stories. Also, Henrik here on the first row, right, who had a lot of conversations about what went wrong in the past. It's always great to learn from these examples. As tragic as they are, hopefully they inspire them and say, hey, you want to be careful when somebody calls you because they found your details, or called somebody else and found your details on LinkedIn and pretend that they're you. Yeah, it's a really tough thing. Yeah. Social engineering.
It's usually things that you wouldn't expect, right? Like, I wouldn't think anything if my coworker who lives in multiple countries has multiple phone numbers registered, right? So, yeah.
All right, one more. Let's see if there's anybody else in the audience. One more
operator.
question.
I'm also going to be around. You can reach me online as well.
All right. In this case, 3, 2, 1. Thank you so much. Another big applause.
Thank you.
All right, so this was day 1 of the KCD Austria. Now, a quick reminder. I think I need to click here or here. If you, Philip, if you do me a favor, just a reminder again. I think it's the previous slide or the next one with the reminder of what do I remind you of? Exactly, the party. So you have about 45 minutes now to get over there. It should be fairly easy. I hope all of you are registered. Now, I got a question to make it even more interesting for you to walk over. Quick show of hands, who of you has met somebody new today? Counter question, who has not met anybody new? You all met somebody new, because I just wanted to say, if you have not met anybody new, then you should definitely go there. Now, for all the others, you take that somebody that you met, go to that party, and continue your conversation. Looking forward to the beers, and last but not least, if you have taken any photos today and you want to share them with us, I think it would be great to put them on social media, whatever you prefer, Twitter, X, LinkedIn, or just send them directly to us. I think tomorrow morning it would maybe be nice to see a couple of those first day impressions. This is the way how we spread the word about KCD Austria, because as I said earlier, this is just the first of many KCDs, and we just wanna, I guess I need a beer. All right, see you later.